Hi, this is Thomas. Welcome back. We're continuing in the lesson on functions. Today we're looking at the concept of the modulus function, also known as the absolute value function. Let's begin by working through an absolute value equation. The absolute value of 2x plus 3 equals 7. Now, the absolute value component of the equation means that we have two possibilities. 2x plus 3 equals 7, or 2x plus 3 equals negative 7. So we solve in both cases for x to arrive at what will probably be two different solutions. So simplifying for the first equation, 2x equals 4 if I subtract 3 from both sides, and x equals 2 when we divide by 2. In the next equation, 2x equals negative 10, subtracting 3 from both sides, and dividing by 2, x equals negative 5. And we summarize as x equals 2 or negative 5. So now let's look at the relationship between a function and the absolute value of the function, and we'll use our equation 2x plus 3, f of x equals 2x plus 3. And we'll graph the line because we want to evaluate the relationship graphically. We have a y-intercept of 3 and a slope of 2, so our line f of x is here. The y-intercept is 0, 3, and the x-intercept is negative 3/2, 0. So now we're going to graph the absolute value of the function and see the relationship between the function and its absolute value. In notation, we can write y equals the absolute value of f of x. We can also write y equals the absolute value of 2x plus 3. And this notation helps us to understand what the graph of the absolute value of the function should look like. Notice that y, the output, is the absolute value of the entire expression on the right side of the equation. Thus, y can never be negative. Now, looking at the graph, the line 2x plus 3 has points with positive y values and points with negative y values. What we're going to do to graph the absolute value of the function is invert any part of the graph with negative y values. So all points above the x-axis remain in the graph of the absolute value of the function. And once we're at the point 3/2, 0, that's when the function turns to negative y values. So we're going to invert, and from that point, we have the mirror image of the function below the x-axis reflected above the x-axis. And the blue line is the graph of the absolute value of function f. This is the process to graph the absolute value of a function. First, graph the function. Second, invert any points on the graph that have negative y values. Let's see a second example. F of x equals x squared minus 3. The curve is a parabola which opens up with a vertex at 0, negative 3. So now let's notate and graph the absolute value of the function. Y equals the absolute value of f of x, or y equals the absolute value of x squared minus 3. And again, looking at the graph, any points with positive y values remain as part of the graph of the absolute value function. And any points with negative y values we invert to complete the graph of the absolute value function. We can label our intercepts. The original function has a y-intercept at 0, -3, and x-intercepts at -√3, 0, and +√3, 0. And the y-intercept of the absolute value function is 0, 3. Again, to graph the absolute value function, start by graphing the original function, and then invert any portion of the line or curve below the x-axis as a reflection through the mirror line of the x-axis. This concludes our lesson on the modulus function. Thanks for watching, and I look forward to seeing you next time.